we're going to finish up what we're going to talk about in Chapter 5 today. And we're going to talk about angle bisectors today. Yesterday we talked about segment bisectors. Today we're going to talk about angle bisectors. So the angle bisector theorem says if a point is on the bisector of an angle, what does bisector mean? Cuts it in half, right? Then it is equidistant. What does that word mean? The same distance from the two sides of the angle, okay? So if we're on a bisector, we're bisecting this angle A right here in two congruent parts, then it's equidistant, the same distance to these two sides of the angle. So these two segments are congruent. So it says if ray AD bisects angle BAC and DB is perpendicular to AB and DC is perpendicular to AC, then DB equals BC. So that's telling you that this right here, this segment is going to be congruent to this segment. They're equidistant to the two sides of that angle. Okay? This one also has a converse theorem. What does a converse theorem do? It reverses the hypothesis and conclusion of a theorem. So if a point is on the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector. So if this is saying if these two are congruent, then this is an angle bisector, meaning these two angles are congruent. So basically what these two things are saying in layman's terms, if these two angles are congruent, then these two lengths are congruent. Or if these two lengths are congruent, then these two angles are congruent. Okay? So if these two are congruent, then these two are congruent. And if these two are congruent, then these two are congruent. So that's kind of like what we did yesterday with segment bisectors. These are angle bisectors, so they work the same way. We know some things are congruent, so we can use equations to help us solve for things in these problems. All right, I'll slowly scroll. All right, so we're going to do that to find missing lengths of segments or missing angle measures. So here's this picture. They tell me that this point right here is in the interior of angle F. They tell me it's perpendicular to these two segments. And they tell me that both of these segments are 7 units apiece. So are those two segments congruent? Yes, if they both have a length of 7 units, then they're congruent. So if they are congruent, then this point must be on the angle bisector. That's what that converse theorem just said. So if this angle, GFH, is 42 degrees, angle GFJ, this angle up top, has to be what? It will also be 42 degrees. Okay? So if these two are the same, then these two are the same. So if these are both 7, and this one's 42 degrees, then this one will be 42 degrees as well. Does that make sense? So that goes both ways. These two things are congruent, then these are. If these two are congruent, then these are. Does that make sense? So the measure of angle GFJ is 42 degrees. That's it. Look at the picture and you can tell. No work to show. You just got to know that theorem and use it. Okay? Questions? Questions? All right. I'm scrolling. It says, for what value of x does P lie on the bisector of angle A? What value of x would make P be on the bisector of angle A? So if P is on the bisector of this angle, then that means these two things would be what? Congruent to each other or equal measures, right? So how do you think I would set it up to find x? Set them equal to each other. That's it. X plus 3 equals 2x minus 1. Get your x's together. I'm going to subtract x. And I'm getting 3 equals x minus 1. Now what? Add 1. And x equals 4. Is that all I have to do on that one? Yeah, it said what value of x. So after you find x, you're done. What if it asks you for the measure of segment BP? Yeah, you'd plug it in and have 4 plus 3 is what? 7. And this one should also equal 7, right? 4 times 2 is 8 minus 1. Is that equal 7 as well? Okay. So it just depends on what your problem's asking. If it asks for the value of x, that's all you have to do. If it wants to know the segment lengths, that you would plug them in. Make sense? The math is really that simple. Scrolling down. We're going to do these out of the book. But we're going to do them together. So I'm going to look at them and see what's going on. Y'all get out your book, please. Turn to page 311 with me. 311. Y'all can get your book out during notes if you don't have to do it during homework, right? It don't hurt us. You have worksheets, dear. It's the same. You're going to finish the packet. Do what? Pretty much. Pretty much. All right, number 1. I will review before the quiz tomorrow, though. So look at number 1. It is toward the bottom of the page where it says guided practice. So it says find the value of x. Now, I'm not drawing those pictures, so y'all need to be looking at that picture on number 1 for me. So it tells me the two angle measures are 27 degrees, so they're both what? They're congruent, aren't they? So what do I know about the length of those segments, x and 15? They're congruent, so what is x? 15 units. Is that hard? No. Okay. Number 2, do you see how it shows that the two segments have those little tick marks? What do those little tick marks mean? They're congruent, so what do I know about the angles? They're going to be congruent. So how can I solve for x on number 2? So I can set 3x plus 5 degrees equal to 4x minus 6 degrees. Does that make sense? Y'all see what I'm doing? They tell me the sides are congruent. I don't know the sides measures, but I know they're congruent because that's what those little tick marks mean. So if I want to find the angle measures, then I can set those two equal to each other because I know they're going to be congruent. So how do I solve this for x? Subtract 3x. So 5 equals x minus 6. And now what? Add 6. So x equals 11. So the direction there was find x, so I don't have to tell you exactly what that angle measure is. Okay? Number 3 is backwards. They tell you the two angles are congruent down there where they have the same little arc marks. So we know that the segments are also what? Congruent. So how do I solve that for x? Set 5x equal to 6x minus 5. So how do I get that equal to x? I would subtract 6x because there's nothing else over there. So bring it to it. What is 5x minus 6x? Negative 1x equals negative 5. And how do I get x by itself? Divide by negative 1. And x equals 5. Is that terrible? No. Well, that is the end of lesson 5.3. So now we just have one more section to do in chapter 5, and it is section 5.5. We're completely skipping 5.4. Is that okay with y'all? Okay. So section 5.5 will finish up what we're going to do in chapter 5. Not really. I mean, there's some theorems to copy. That'll take y'all longer than actually doing the math, but the math is easy. We did 5.3 and then we did 5.5. I don't know. What? Use inequalities in a triangle. Sorry, I wish my thing was like shifted down lower. No, it's the way it's mounted up there. I've bent and almost broke it. So it's because my pole is not long enough, and I've tried to work on it.
You can roll your screen up a little bit. No, it's the light. Will be. It fits. Oh. Ah.
Is that better? I'm afraid it's gonna like. I didn't have enough coffee today. Maybe I need to save it to you. Okay. So we're going to talk about inequalities in a triangle in this section. And this is a pretty little simple lesson. It pretty much tells us what can make a triangle and what cannot make a triangle. That's pretty cool. Because not every set of sides can form together to make a triangle. Right? Just because you have three sides doesn't mean they fit and meet up and make a triangle. Okay? Something that's really cool about triangles is the largest angle is always across from the longest side. The largest angle is always across from the longest side. Always. That's pretty cool. And the smallest angle is always across from the shortest side. So if you know the angle measures, then you can pick out the smallest side, the medium-sized side, and the largest side. So the largest angle is always across from the longest side, and the smallest angle is always across from the shortest side. And that's going to be some things that we will answer on our quiz tomorrow and on our handout today. I'm going to scroll so you can copy a few theorems. Now, you don't even have to write these down. Let me read it. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle of. Okay. Yeah. So this is basically what that picture just said. Okay? The largest angle is across from the longest side, and the smallest angle is across from the long side. You see that? You see how all that wording just said what that little picture I had said? Right? That's what all those words mean. All right? So you okay that we don't have to write this down? Is it going to kill y'all's soul? You already started, so you want to finish it, don't you? Y'all are OCD. Okay, now this one you do need to write down. This one is different. Okay, so those two theorems basically said what I told you. The largest angle is across from the longest side, shortest angle is across from the smallest side. And of course, the medium-sized angle is across from the medium-sized side, the one in the middle of the two. And here's the second cool thing we're going to talk about in this lesson. And like I just told you, all three sides of different lengths don't necessarily form a triangle. Let me see if I can draw an example. I have some examples on paper I can show you. If I have one this length, and one this length, and one this length, does that make a triangle?
No.
It's got three sides. Okay, well this side goes longer than it should, right? Right? So this side, if I had like a piece of wood or whatever, that don't form a triangle. I'd have to chop it off. Y'all see that? Likewise, does that make a triangle?
Coach Jones, come to the office.
No, it's got three sides of three different lengths, but they don't even meet up. Y'all see what I'm saying? So just because you have three sides does not mean they make a triangle. So the triangle inequality theorem tells us when sides will meet to form a triangle and when they won't. Okay? So what you're going to see is three lengths of three possible sides to a triangle, and they're going to ask you, can these three sides form a triangle? And you're going to tell them yes or no. And here's how you're going to figure it out. The sum, what does sum mean? You're going to add them together. Okay, so if I add two lengths of any two sides of a triangle, it must be greater than the length of the third side. So if I add any two lengths of any triangle, their sum added together must be greater than the third side. All right? So say I have this triangle, I'll do small numbers. 3, 4, 5. Now I drew it as a triangle, but does that always work? Well, if I add 3 plus 4, is that greater than 5? If I add 4 plus 5, is that greater than 3? And if I add 3 plus 5, is that greater than 4?
What do you do 1, 2, 3?
I don't have a 1.
No, I'm saying like what if it's a triangle?
Exactly. Exactly. So this would be a possible triangle, right? This could work. So what if I have, like she said, 1, 2, and 3? It doesn't matter. All you need to know is the side lengths. Is 1 plus 2 greater than 3? No. So these three lengths would not meet up and form a triangle. 3 equals 3, but it's not greater than 3. Does it say greater than or equal to, or does it say greater than? See that? So this is greater than this. This is not greater than that. Does that make sense? And I'm going to show you, when we go to the worksheet, I'm going to get you started on it a little bit. Few examples. Okay, this is just examples of the longest triangle, or the longest side is across from the largest angle stuff. List the sides of triangle RST from shortest to longest. And I told you at the beginning of the lesson, the shortest angle is across from the smallest across from smallest, right? So which one of these is the smallest angle? 29 is the smallest angle, right? It's the lowest number. So it's across from, so this is going to be my small, I'm going to call it 1. I'm just going to put it in order, 1, 2, 3. Does that sound good? So there's my smallest one. What's my next smallest one? 30, so it's across from 30, so that's RS. So it means the longest one is across from the largest angle, which is this one. So if I'm putting them in order, ST is the shortest side, the next shortest one is RS, and the longest one is RT. That's not, I just numbered them in order from shortest to longest. Those are not the measures. Number 1. Number 2. Okay? So you just go in order. Go across from it. 29 was the smallest, so this is the smallest side. 30 was the next smallest. This is the next smallest side. That was the largest. It was across from the longest side. Okay? Questions? I got this triangle. I know two sides are 12 and 8. I don't know the measure of this one. So it's just asking me some questions about it. Can the third side have a length of 21? Why not?
Because 12 is longer than that one, and that one's.
Yeah, if I add the other two, that's not greater than 21, is it? No. So, nope, can't be that.
And the longest side is 12, so that one doesn't make sense.
The longest side is not 12. The longest side is now 21.
You can't look at the picture.
No, you can't look at the picture. You have to go by measurements.
I thought 21 was it doesn't work.
Coach Jones,
No, it's not.
office, please.
Okay? You got to go by measures. They give you measures. Okay? So the third side cannot be 21. Can the third side have a measure of 5.5? Which two are the smallest two? If I add that, is it greater than 12? Yeah, because that's 13.5, isn't it? Is 13.5 greater than 12? Yes, so I could have a possible side of 5.5. Yes, it is. It's 20. 20 is greater than 5.5. So the quick way to check it, y'all, is to add the two smaller ones, right? Because you know if you add the two smaller ones and it's greater than the third one, then you know the rest of them is going to be greater than the other ones, right? Right? So that's really the ones you need to check, is are the two smaller ones added together greater than the largest one. Okay? And if that's the case, then yes, it makes a triangle. If not, it doesn't. Well, that's going to be the end of notes. And we're going to work on our worksheet packet now. Have a good day. If you weren't here, study for your quiz.